Hello everybody, I'm Kien from Deakin University. Today I would like to present my work accepted to the CredD 2019 with a graph transformation policy network for chemical reaction prediction. This is a joint work with Truyen and Svetha Venkatesh. First, I would like to say that chemical reaction prediction is a practically important problem because if companies or organizations can predict the products of chemical reaction with high accuracy, they can save a lot of money and labor from running real experiments. In addition, they can accelerate the process of planning and synthesizing new substances. Previous methods for this problem are mostly rule-based and template-based. This method usually requires to define hand-crafted rules. They are neither scalable nor generalizable, and it is difficult to train this method end-to-end. So the question is, how can we overcome all these limitations? Our intuition for the chemical reaction problem is that we can represent molecules as graph and represent a chemical reaction as a set of graph transformations. From that intuition, we propose a model named Graph Transformation Policy Network. As you can see in the picture, our model looks like a sequential model, but it does not assume any order of the input sequence. Instead, the input at the next step depend on the model outputs from the previous step. This means that the order is decided by the model itself. This is how we handle a set of graph transformation. For the detailed function at each step, we categorize them based on the three main components of our model, which are graph neural network, node pair prediction network, and policy network. We use a message passing graph neural network to compute embedded vectors for all atoms in the reactant molecules. Then, from the structural information provided by these embedded vectors, we compute the score for all atom pairs using the node pair prediction network. The scores are normalized between 0 and 1, and higher values indicate that the corresponding atom pairs are likely to participate in the reaction. Because processing all the atom pairs in a molecule is very expensive, we only select the top k atom pairs with the highest scores. Finally, our policy network will base on the top k atom pairs to find which ones should be modified at the current step and what is new bond type. This network also produces a binary signal to indicate that whether the model should continue prediction or not. Here is our objective function, which is composed of 4 different terms. You can find the interpretation of each term in our paper. Here is the main result. You can see that our method achieves better top 1 accuracy than other baseline methods on the 2 large datasets. In summary, we have proposed a method to solve the chemical reaction prediction problem, which does not require hand-crafted rule, can be trained end-to-end, and can be applied for any kinds of chemical reactions. Thank you for watching.